Hello, today we'll learn about primary trigonometric ratio, and we'll start with the application of sine ratio. First, just I will give an overall introduction to all three primary trigonometric ratios that we use, and then I will focus on this lesson. I will focus on sine ratio only. We'll use it to find missing side lengths that involves either opposite or hypotenuse side length, and we will also find an angle when opposite and hypotenuse is given. So there are three main primary trigonometric ratios that we use, and the abbreviation, the way we remember these primary trigonometric ratio is says so ka toa. SOHCAHTOA. So this is how we remember all three basic primary trigonometric ratios. So I'll explain what these are, and then we'll focus on sine ratio. So my first focus is on sine. So S stands for sine, so it is sine theta equals O is for opposite, the side length opposite, and H is for hypotenuse, side length hypotenuse. Okay, ka is for, C stands for cosine. This is cosine theta. A is for adjacent. Adjacent over hypotenuse. Side length hypotenuse. Okay. And TOA is tangent theta. T stands for tangent. So it is tangent. Theta is a Greek letter for unknown angle. O is for side length opposite. And A stands for adjacent side length. Adjacent. Okay, so I'll just explain a little bit, which side is opposite, which is adjacent, and which side is hypotenuse. So I'll scroll down. So always remember, these primary trigonometric ratios are only applicable in right triangles. So what is a right triangle? A right triangle is a triangle in which one angle is of 90 degrees, okay? So this little box, if you see a box in a triangle, that means it's a right triangle and it's equal to 90 degrees. The side opposite to this little box is always the longer side, and it's called the hypotenuse. So this is the hypotenuse. Let me write it again nicely. So this is the hypotenuse. Okay. If we have, let's say, if we are working on this angle, and if this angle is either given or we are asked to find it, then the side opposite to this angle will be the opposite side length. So this is the opposite side length. And the remainder side length is adjacent. Okay, I'll scroll up and play a little bit more with the side lengths, just to make sure it's clear and you students understand it clearly. So I'll just flip this right triangle a little bit. Okay, and this is the, let me draw a straight line. Okay. So this looks a little better. So, and if we are working, if this is, let's say, angle B, and we are working with this angle, either this is given, let's say this is 25 degrees, then our opposite side will be this side, opposite side length. Okay, so this will be our opposite side length. And this is the hypotenuse, the longer side length. and this is the adjacent. Okay. Now I hope it's clear how to determine the side lengths, because this is very important. If you are able to determine the side lengths, you'll be able to use primary trig ratios effectively, and you'll be able to solve different kinds of questions. Okay, let's do a couple of examples. If a right triangle is given, and remember we'll be working on sine ratio in this lesson. This is a right triangle, and sine ratio is equal to, it is equal to, so sine is equal to sine theta equals opposite over hypotenuse. Okay, and if this angle is given, let's say this is angle A, is equal to, let's say, 45 degrees. So the opposite side is this one, and let's say it's given, it is 24 centimeters. And the question is, find hypotenuse, find this side length. Okay. I'll just write it nicely. So hypotenuse. Okay, and this is adjacent, so we don't need adjacent because we're just using opposite and hypotenuse. We're asked to find the length of hypotenuse, and opposite side length is given. So what we're going to do is we'll plug in the numbers. So it is sine theta is 45 degrees equals opposite is 24, and it's centimeters divided by, so this is opposite divided by x, because hypotenuse is unknown. I'll just write 1 there. We'll cross multiply. So sine 45, and in parentheses I will write x, and 24 multiplied by 1 is 24 centimeters. Now we'll divide both sides by sine 45 degrees. In order to get rid of sine, because it's multiplying with x, in order to get rid of sine 45 is to divide both sides by sine 45 degrees. So it'll just cancel out, and we are left with x equals 24 centimeter divided by sine 45 is, I'll punch in sine in my calculator, and 45, it is 0.707, and 24 divided by 0.707 will get 33.95 centimeter. So our hypotenuse is 33.95 centimeter. That will be our answer. Okay, so this is the example how to find hypotenuse. If the hypotenuse is given and we are asked to find adjacent, we'll do another example for that. So this is our, so this is another right triangle. That's 90 degrees angle. Let's say this time I will just switch around the angles, and let's say this angle is given as 23 degrees, and hypotenuse is given as 28 centimeter, and we are asked to find opposite side length. Okay. So this is the opposite side length, and this is adjacent. So we don't need adjacent. We are not doing anything with adjacent, because I'll just erase this opposite. I'm going to write it nicely. Okay, so that's the opposite. And this is 23 degrees. It's not 230, okay? So we're going to use sine ratio because we are dealing with opposite and hypotenuse, okay? And we'll solve this question. So sine 23 degrees equal opposite is x because it's unknown, and hypotenuse is 28 centimeter. I'll just write down 1 there. I'm going to cross multiply. X times 1 is x. I'll multiply these two. So it is sine 23 degrees times, so this is, let me write it nicely, sine 23 degrees times 28 centimeter. So sine 23, I'll punch in the numbers into my calculator. So I'll push sine first and then 23, and it's telling me it's equal to 0.3907. I'm going to times it with 28 centimeter times by 28 centimeter. So I will get 10.94 centimeter. So that is going to be our final answer, okay? So this is how you'll find the opposite side length using sine ratio. Now, if the question is to round your answer to a nearest whole number, so this will be 11 centimeter. If there is no restriction, just use 2 decimals after 2 decimal points, 2 digits after the decimal. Okay, we'll do another example and we'll use sine ratio to find a missing angle. So this is our right triangle. Okay, and we have to put this box in just to make sure it's the right triangle. Okay, we're asked to find this angle A. And if you are using sine ratio, then opposite and hypotenuse should be given. So this is the opposite side length, and let's say this is equal to 14 centimeters, and hypotenuse is 36 centimeter. Okay. Now we'll use these two side lengths to find angle A. So it is sine theta, or you can say sine A equals opposite is 14 centimeter divided by 36 centimeter, which is the hypotenuse. We'll say theta equals sine power negative 1. We'll take the inverse and we'll divide 14 divided by 36. We will get 0.388. Now we'll take the inverse of sine, the second function, sine 0.388, and the angle I got is 22.8. I will just round it up to 23 degrees. Okay, so that's the missing angle, and this is how you will use opposite and hypotenuse and using sine ratio to find this angle. Just to recap, the three main primary trigonometric ratios and its application is very easy. You just need to know what it is, and it's always applicable in right triangles. You can use it in construction, building different things, and you can determine all different side lengths. And the short form that we try to remember is SOHCAHTOA. So sine theta equals opposite over hypotenuse, cosine theta equals adjacent over hypotenuse, and tangent theta equals opposite over adjacent. So on this lesson, we only focus on the application of sine theta. Thank you very much. And